Okay, with simplifying radicals, I relate a lot of the radical stuff to fractions. A lot of the same ideas, if you will. So if we are simplifying radicals, so if you have, first of all, there are some rules, and these are rules that definitely apply to algebra 1, 2, and when you start getting into the higher levels of math like R3, 4, then it starts changing ever so slightly. Okay, so here are some rules for radicals. You cannot, one, leave a perfect square under the radical. Let's zoom in just a little bit. You cannot leave a radical in the denominator of a fraction. I'm going to abbreviate it. You cannot leave a fraction under the radical. And for our purposes, you cannot have a negative number under the radical. That changes when you get into algebra 3, 4 and with the introduction of imaginary numbers. Okay, so perfect square. You have to be able to identify and recognize the perfect squares, and we talked about those today in class. So the square root of 4 is a perfect square because that's the same thing as 2 times 2. Okay, so square root of 4 equals 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. I probably should have put in the square root of 1 is 1 because that's one that gets missed actually quite a bit. And you should recognize, especially some of these smaller perfect squares, but you should know them all the way through the square root of 625, which is 25. So you should know and be able to recognize those. When you simplify a perfect square, so if you have the square root of 25, we already did this one, but it equals 5. Because 25 is the same thing as 5 times 5. If you circle your pairs, you take one of them out, which gives you the 5. If you have the square root of 40, now there are two different ways of doing this. I'm more apt to do the prime factorization method as opposed to the perfect square method, just because a lot of students don't recognize the perfect squares that are hidden within numbers. So the square root of 40 is the same thing as 4 times 10. 4 is the same thing as 2 times 2, and 10 is 2 times 5. You circle your pairs, and that number, one of those goes outside the radical. All the other stuff that you did not circle gets multiplied and put back under, which is 10. The reason why we are dealing with pairs is because if you look at the inverse of this, 3 squared equals 9. So that's where the pairs are coming from. So you have 2 radical 10. You can check this by going backwards. So if you have 2 squared, so 2 squared gives you 4. 4 times the stuff under the radical of 10, and that does give you 40. So that should be the same as what you started off with. Here's another way of doing this. Again, this is not the method that I will be choosing. that the square root of 40 is the same thing as the square root of 4 times the square root of 10. I recognize the